Okay. Wait, what? Why? Or are they saying it's 4.5 and they're pulling 2 meters? They're saying the distance at the bottom, like just like where it's at the
our AP test. Here we go. 6.21 meter long pendulum is pulled from rest position, so this point is 2 meters above, and 4.57 meters horizontally placed from its rest position. It is then released. Assume the positive X side, so we'll assume it's over here being released. At 0 seconds. What's the amplitude of the motion? We only consider the X direction, so that would be what? Amplitude would be 4.57 meters. How far we displace this sucker? Next one, B. How much time until it returns to the starting position? That would be a period of time. So you go period equals 2 pi square root of L, which we just said was 6.21, divided by G, which is 9.81, or 9.80 in this class. And what do we get?
5.
Somebody said 5. 5 really it? 5? Second? Sounds like something I would do. Flipping it over. C. So the time it is released, how much time until the first time it reaches the rest position, which we changed to equilibrium position, which would be where it's in the middle, right? That is 1/4 of the whole trip, right? And what's 1/4 of 5 seconds? 1.25 seconds. So 1.25 seconds is when it returns, when it first goes through the bottom of its sweep. Moving on. What time would it be at its highest, bud?
0, 2.5.
What time would be its highest? 0 or 2.5 would be the next time's highest. 5, 7.5, yeah. So she say first time, but that would be 0, 2. So 0, 2.5, dot, dot, dot. 5 seconds. It doesn't say first time. It's kind of weird to say that. E. How fast is it going when it passes the rest position? Uh-oh. Well, we know. Energy before equals energy after is the way we're going to approach this, right? What kind of energy drives a pendulum? Potential energy. So I'm going to go mgh is equal to 1/2 mv squared. Notice the mass cancels out. G is 9.8. How high did I raise it? 2 meters. 1/2. What's the velocity? I don't know, but that's what I'm looking for. So it's okay. I don't know that. What'd you get? That seems low. Hold on. Let me do the math again. 4 times it should be about 40. Square root of 40 should be about.
It's 6.3.
Yeah, 6.3 is what I'm getting. I did something wrong there, but 6.3 sounds right to me.
Yeah, it is.
How fast is it going at its highest point? 0. How fast is it going at the bottom? That's a dumb question. We already asked that question. 6.3 meters per second at the bottom spot. What kind of dumb question is that? Cross out G, it's a dumb question. H. Sketch the amplitude versus time for the first 15 seconds. So, amplitude versus time. We just said the amplitude was what? 4.57. And I'm going to, this is 5 seconds. This is 10 seconds. This is 15 seconds, right? You go through a full cycle every 5 seconds. So that means I'm going to go whoop. By the way, if I did the y component as well, all I'd do is change this number. The exact same thing. Except it bounce. Okay. Sketch potential energy for the first 15 seconds. Potential energy would be maximums here and here, right? So right underneath. At 0, I have maximum potential energy. At this point, I have max potential energy. At this point, I have max potential energy at 5 seconds. I have maximum here. I have maximum here at 10 seconds. I have maximum here. I have maximum here, because those are the times when it's farthest displaced. That's maximum potential energy, right? from the equilibrium position. Whoops. This is 15 seconds here. So here we go. Maximum, minimum. Uh-oh. Oh, that's a weird 15. Okay. All right. You officially know everything you need to know to pass this test. The only other thing I would worry about a little bit is Mr. Bibele. Could you write an equation for that? How would you go about that? So it'd be y equals, I would use cosine because I'm lazy and it's maximum. So this isn't a math class, so we can do whatever the heck we want. So I would use cosine. I would note that the amplitude would be what? 4.57. I would then recognize that I have a t here. Since I got rid of the phase shift, I won't worry about that. Generally speaking, you won't have to worry about phase shifts or vertical shifts. I do have to figure out what k is. What's k? K equals 2 pi over the period, right? Or period equals 2 pi over k, right? But just flip it around when you do that. So this is just 2 pi over 5, and I have my equation. They could ask you for that, or they could give you that and ask you to graph it. Those of you who are currently in calculus, I have my apologies. I don't think you covered this very well last year. And those of you in trigonometry, you have to dig up your memories because it's been months. That could happen to you.